So as Nathan said, I am one of the primary maintainers of an open source project called PouchDB, which is a JavaScript database that runs in the browser and Node.js. And it is a JavaScript reimplementation of CouchDB, which is kind of neat because then you can sync it from the client to the server, from PouchDB in the browser to CouchDB on the server. Does anyone here actually use PouchDB? Just out of curiosity? All right, cool. A few hands. Yeah. Yeah, it's part of the Hoodie project as well. So if you used Hoodie, you've used PouchDB. But I'm not here to talk about that. I'm here to talk about something I love very, very much, the web. And this talk is going to be about building rich, immersive experiences on the web in such a way that the web can be made more competitive, especially on constrained mobile devices. And I have to start this talk off on kind of a dour note. Like, I'm sorry about that, first thing in the morning. But the talk is going to kind of start off down here. We're going to be feeling bad. But then by the end of the talk, we're going to be up here. We're going to be feeling real good, OK? But just bear with me. It's going to start off a little dark. So I have to point out that the web has a problem. Now, this particular problem isn't a new problem. It's been around since the beginning of the web. But it's an interesting problem. And a lot of people are aware of it. But even those who are aware of it might not have fully thought through the ramifications of it. So what is this problem? Well, you can reproduce it really, really easily. You can try this at home yourself. All you need to do is put an animated GIF on a web page, any old web page, and then do some long-running JavaScript operation. Like here, I'm doing math.random in a loop 1,000,000 times. This is super dumb. Like you'd never actually do this in a real app, but this is just for demonstration purposes. And what you'll notice is that the animated GIF, when it's running the JavaScript, it just comes to a complete halt, right? Like the GIF just stops. And this is in Firefox, but you can reproduce this in every browser. You can see this in Safari, in Chrome, in Edge. Like when the JavaScript is running, the GIF just comes to a grinding halt. Now, that would be bad enough if it was just animated GIFs, right? We love GIFs. We don't want our GIFs to stop. But as it turns out, this actually applies to just about anything that moves on your page. So HTML5 video, JavaScript animations, CSS animations, except for hardware-accelerated CSS animations, but most CSS animations, they just stop. And even form elements. If I've got form elements on my page, I can't interact with them while the JavaScript is running. The page just becomes, like, see, I'm trying to click, and I can't even click on that checkbox. I can't enter any text in that text input. I can't check any of the radio buttons. Like, while the JavaScript is running, this page just completely becomes non-functional. All right. And the reason for this, as many of us know, is because JavaScript is single-threaded, and the DOM is single-threaded. And whenever JavaScript's doing something, the DOM can't do anything, and vice versa. And that's kind of a mind-blowing thought if you actually let the gravity of that statement sink in on you. Because if you think about that deeply, what that statement means, and this is true, is that every line of front-end JavaScript that you've ever written has, at least momentarily, completely stopped your web page from working. That's true. That's what that means, right? And when you realize this, it kind of impresses upon you this huge responsibility that we have as JavaScript developers because we have the power to totally break our pages, right? That's what we can do with JavaScript. It makes you realize that we have this huge power, but also this huge responsibility. Spider-Man JS. But I mean, most of us are very responsible with our JavaScript. We know not to use it too much. So we know not to do these gigantic, for loops where we execute math.random 1,000,000 times, right? That's just dumb, right? But have you ever made a page or seen a page that kind of looked like this? So watch those animations. It's not so much that they're completely stopped. It's like they stop, and then they start, and then they stop. And I can interact with the page. It works. And I can even scroll. But when I scroll, the scroll bar kind of gets a little stuck, right? Like, this page works. Like, you can't say it's a broken page. It's functional. But just something feels off about it, right? You almost get like kind of a sickening, like uncanny valley feeling. There's something wrong with the page, right? You got this like stop motion kind of animation going on, and it just kind of doesn't work. And this effect goes by many names. We call this jank or jitter or stutter. There's lots of names for this. And what this is not one long JavaScript operation that just stops the page for seconds on end. This is lots of little JavaScript operations adding up over time. This is death by 1,000 cuts. This is what it looks like. And we've all seen this, right? Like, especially on the mobile web, we've all seen this. This kind of janky page, this is the scourge of the mobile web, right? Now, of course, we know the solution to this problem is not to just stop using JavaScript. That's not really feasible. Like, we want interactivity on our pages. So exactly how much JavaScript are we allowed to get away with before we start getting this janky effect? Well, we can answer that question with some math. So most screens are set to refresh at 60 frames per second, which means that they're flashing 60 images in rapid succession every second, which gives the illusion of motion, exactly like this old-timey flipbook. Like, it's exactly the same parlor trick that worked 100 years ago, and we're still using it today. It's kind of fascinating. And it turns out that 60 frames per second is about the limit of what your eye can detect in terms of something looking smooth versus looking janky. As soon as you start to drop below 60 frames per second, like you get into like 50, 45, or especially 30, 25, you start to get this stop motion janky appearance. And if you do the math on this, if you take 1,000 milliseconds and you divide it by 60 frames, you come up with this number that many of you may have heard of, 16.7 milliseconds, right? And what this number is, this 16.7 milliseconds, this is the amount of time that any synchronous block of JavaScript that you have must complete in, or else you risk dropping frames, or else you risk missing that 60 frames per second mark. So 16.7 milliseconds, that's like nothing, right? That's like less than the blink of an eye. That's 16 thousandths of a second. That's tiny, right? How are we supposed to get any JavaScript done in that amount of time? And just wait, because it actually gets worse. Because if you listen to the browser vendors, like Paul Lewis on the Chrome team, he'll tell you that when you factor in browser overhead, the stuff the browser has to do to be a browser, you actually have more like 10 milliseconds to work with. So the browser takes its cut, and then you're left with 10 milliseconds, 1/100th of a second, which is just punishingly tiny, right? If you want to hit this 60 frame per second mark. And this is a really, really awful situation even on desktop. If you think it's bad on desktop, it's even worse on mobile. This is the kind of thing that leads people like Jeff Atwood, also known as Coding Horde, to write these kind of blog posts. Like he wrote this blog post last year about where he says the state of JavaScript on Android in 2015 is poor. And basically what he says in this article is that Discourse, which is a large Ember application, just can't run fast enough on your average Android device. Android devices, the single-threaded JavaScript performance is just too poor, and it can't run Discourse at a reasonable speed. iPhone is just fast enough, but Android phones, the hardware is not so good, V8's not so good, so they just can't run fast enough. And this is the kind of situation where, when people look at this, they say to themselves, oh, so this is why we can't write a mobile web app. Right? This is why the web's not good enough. This is why we have to go and write a native Android, iOS app, or we have to write a React Native app because the web's just not there. And I take exception to that viewpoint because I've actually done native Android development. I actually did native Android development for years before I started doing web development, and I know the tricks that Android and iOS developers use to get around this problem, and I'm here today to share that trick with you. So it's very simple. You take a look at some of the middle-of-the-road Android phones that are being sold by T-Mobile. This is from T-Mobile's page. And these are the kind of phones that, if you ran these through Ember's benchmark or SunSpider benchmark or one of these things, it's going to score pretty poorly. Single-threaded performance is not very fast in these things. That's the key word, single-threaded performance. If you actually look at the processors on these things, what you'll discover is that all of these, even the cheap ones, they have 4 cores. Some of them have 6 cores or 8 cores, right? And it's been this way in Android for years, and in iOS as well. So, yes, these phones are slow, but they can do 4 things slowly at once. That's great. And so you ask Android and iOS developers how they deal with the situation. Whenever we want to do something that's going to be long-running, we just put it on a background thread. We just do things in parallel. We use the cores that are available instead of milking this one core and trying to squeeze out the best possible single-threaded performance. And the solution to this problem on the web, which we have, this is not just something that's available to native developers, is called web workers. So I spent a lot of time on this slide. I hope that it's I hope the effect is good. Yeah. And also, I did this effect in JavaScript, and I made damn sure that I didn't block those GIFs. Because I love those GIFs. But yeah, we have the tools are available to us as web developers. This is not just something that is in the toolbox for native developers, and it's their domain, and we can't touch it. No, we can do things in parallel on the web, and it's with this technology called web workers. And the way that it works is very, very simple. This is all the code in the world that you need to run a web worker. This is all vanilla. You don't need a library. You don't need a framework. All you do is you have, in your main JavaScript on the left, you create a new worker. You pass in a path to a worker JavaScript file. Inside the worker JavaScript file on the right there, you can listen for messages. You can send messages back and forth. And crucially, inside of that worker thread, anything you do in there will not block the DOM at all. It is running on a totally separate thread. Depending on the implementation, it's on a completely separate process, even. And you can communicate with it using asynchronous message passing. And you can pass lots of kind of objects back and forth. You can pass strings back and forth, JSON, array buffers. And this is the way that it works in terms of code, but I like to explain these things visually. So the way I like to think about it is this. Of course, I'm going back to Kirby GIFs. But there's this thing called the UI thread, or the main thread, that exists. And its main job is to paint. Its main job is to listen for user input, like swipes and taps and clicks, and to paint. And this concept extends beyond the web. Like, you talk to Android and iOS developers, and they will tell you about the UI thread or the main thread as well. And this thread is very, very busy, right? Like, you'd be busy too if somebody asked you to paint something every 16 milliseconds, right? Like, yeah, you'd be tired. And what are we as web developers doing to this poor, overworked guy who's trying to paint every 16 milliseconds? Well, we're sending down our 500 kilobyte JavaScript app, and we're telling him, hey, all that painting you need to do, why don't you do a bunch of other stuff too in the meantime? You know, why don't you do your JSON parsing, JSON stringifying, all your business logic? Why don't you do local storage and do Ajax? Just do everything on this one thread. And this is what it looks like. So of course it can't keep up. Of course it can't paint every 16 milliseconds. Like, we're asking him to wear too many hats. So what we'd like to do is we'd like to have him spawn some friends, right? We'd like this thread to be able to have some friends that can work alongside of him, and he doesn't block them, they don't block him, they can do work at the same time, and they don't block each other, right? Spawn some friends. And this is exactly what web workers allow you to do. You can spawn as many web workers as you want. You could spawn one web worker per core if you really wanted to. Like, you don't need to. I'd say spawning one web worker is good enough most of the time. But I mean, you could. Like, we could have applications that are actually using all 4 cores on those mid-range Android phones. Like, instead of having an application where just one core is trying to do everything, you could have an application that looks like this, right? You could have the one thread that's doing the painting, responding to user input, the other one that's doing your business logic, another one doing JSON, parsing, stringifying, another one doing Ajax, IndexedDB. Like, we can build this on the web. These tools are available to us as web developers. Now, it's important to talk about what exactly web workers can do, because it is true that they can do a lot of things, but there are some crucial things they cannot do. So first off, what they can do any, like, your standard JavaScript, anything you're used to doing in, like, regular synchronous JavaScript code, they can do. They can also do JSON parsing, stringifying, base64 stuff, B to A to B. They can do file reader, blob, array buffer, all the kind of stuff for, like, working with binary data. So if you want to do heavy computational kind of jobs, like, this is perfect for web workers. Another thing you can do in web workers is pretty interesting is IndexedDB. And this is pretty interesting. You cannot do local storage, lowercase l, capital S, inside of a web worker. And the reason you can't do that is because local storage is synchronous and slow, and it's got limitations, very low limitations in most browsers. It's got race conditions, so it'd be weird to use it inside of a web worker. So browser vendors make IndexedDB available. They're trying to push us to use IndexedDB more than local storage. And you might think to yourself, like, what is the point of using IndexedDB in a web worker? Because it's asynchronous, right? Like, I tell it to do something, and I give it a callback, and then it comes back and tells me, you know, it calls that callback later when it's done doing its thing. All right, that doesn't block, right? All right, asynchronous is free, isn't it? Well, it's actually not. And I have this tool to demonstrate this called database comparison. This is a great way to freeze your browser. If you want to freeze a bunch of browsers, this is the tool for you. You can go in there, and I'm inserting a bunch of documents into IndexedDB, and I can easily freeze the DOM. And I can freeze the DOM with any storage mechanism. It's true, local storage, because it's synchronous, does block the DOM more than IndexedDB, but IndexedDB actually does block the DOM pretty heavily. And the reason for this is because, yes, it is asynchronous, but there are things that the browser just has to do, even if it's asynchronous. Like, it has to allocate event listeners, it has to do structured cloning. There's just stuff the browser has to do. Whereas if you do any of this inside of a web worker, if you do IndexedDB inside of a web worker, it's smooth sailing. It does not block the DOM at all, not 1 nanosecond, because it's on a completely separate thread. Another interesting thing that web workers can do, they can do Ajax or fetch, right? So we can call our remote servers and get a response back. And again, you might look at that and say, like, why would I want to do that? Because Ajax is asynchronous, right? I give it a callback, and it calls me back with the response. That's free, right? Well, as it turns out, it's not. And this is another thing that I encourage you to try at home, because you can simulate this with good old-fashioned jQuery $.Ajax. Just do too many Ajax requests, or do Ajax requests for too large of an object, and you can easily freeze the DOM. Like, this is, because there is stuff in there that the browser has to do in order to handle this request, especially if you're requesting a large JSON file. And God help you if you want to parse that JSON file, right? Because JSON parse is also done on the main thread. That's synchronous. So you can easily block the DOM with this stuff. Now, obviously, this is kind of a contrived example because I'm doing 500 Ajax requests, and you probably wouldn't want to do that many. But this is just to make it visual so you can actually see it. And what I want you to think about when you see this is think about all those little Ajax requests that are going on in your application, things like trackers and ads and maybe syncing operations that are going on. And all those things are just kind of adding up, right? They're just nicking away at that 10 millisecond budget that you have, right? So this is just one more thing that if you do it inside of a web worker, absolutely zero cost to the DOM. So you can do all this stuff inside of a web worker, and you may start thinking like, okay, that's pretty awesome. I can almost put my entire application inside of a web worker. That's sweet. There's one thing you can't do inside of a web worker, though. You cannot do DOM. So there's no window, there's no document, there's none of that stuff inside of a web worker because it's a completely separate thread. But I got kind of interested by this idea recently because I was thinking to myself, like, most of us aren't directly accessing the DOM anymore, right? Most of us are using virtual DOM or abstractions on top of the DOM. And virtual DOM doesn't require the DOM, right? So can you do virtual DOM inside of a web worker? And the answer is you can. And I proved this by writing this app called Pokedex.org, which I encourage you to go check it out. It's a Pokedex. I actually did get the Pokedex.org domain. I was super happy about that. Just no one had taken it, so I took it. It's free. Or it wasn't free. It was like $10 a year. Whatever. It's totally worth it. And basically what I'm doing here is every time there's a user interaction, a tap or a swipe or whatever, that happens on the main thread. That happens on the UI thread, right? And as soon as I get that event, it's like hot potato. I just want to get rid of it. I want to put it on the worker thread. So I immediately throw it off to the worker thread. The worker thread does all the work, and then it comes back to me with the answer and says, here's what you need to do to update the DOM. And this runs really, really well. Like, I've got this running, let me get to that later. This gives you this architecture that is really, really interesting, I find. So in the lower right-hand corner, you get an action in on the UI thread. And then that action gets passed as a message to the worker thread. And basically, you can kind of think of this as being like, I sort of implemented a kind of flux pattern where I stuck flux inside of the web worker. And inside of the web worker, I get this action from the UI thread that says the user tapped or they swiped or whatever. And then inside of there, I do IndexedDB operations, I do Ajax operations, and then I do virtual DOM. This is where it gets interesting. So virtual DOM has 3 stages, right? You generate the tree, you diff the tree, and then you patch the DOM. And notice that those 3 steps, only the last one actually required the DOM, right? So inside of this worker thread, I can render the virtual DOM, I can diff it, and that's the really expensive part, right? That's the part that's like, I think Christopher Shadow said it was potentially order n cubed, right? It could be really, really bad. Like React had to implement so many heuristics to make this more efficient, right? And Ember is doing the same thing with Glimmer and Glimmer 2. All these efforts to shave away these precious milliseconds that don't matter so much if you're running it on a worker thread, right? So I'm doing this virtual DOM diffing inside of a worker thread, and then I end up with a patch. And this patch is the minimal set of DOM instructions that need to be applied to update the DOM to the new state, right? And this patch object is what I send across, and then the UI thread just like stupidly just executes the operations. And it's good that this patch message is kept kind of small, because that is the one cost that you pay with web workers, is the cost of sending messages, because there's no shared memory here. It's not like other programming languages. And there are tricks to make that faster, and I have a blog post linked at the end of this that explains how to do that. TLDR, JSON.stringify the messages, and it's magically faster. It's pretty cool. And this works really, really well. Like I got this running on a 2011 Galaxy Nexus, which is a 5-year-old phone, and most of the app will run at 60 frames a second on this thing. And this is an old janky phone. Like this thing struggles with native apps, but like it has 2 cores, so like it can do 2 things at once. It works really, really well. On a newer Android phone, I'm happy to say it's indistinguishable from a native app. I showed this to fellow native Android developers, and they were amazed that it was a web app. I also did some measurements just to kind of see what workers were buying me. I did some measurements in the Chrome profiler. This is what it looks like if I take the web worker out and I do everything on the main thread. And basically what you should take away from this is that there's a lot going on, right? I'm doing all these computations, IndexedDB operations, rendering the virtual DOM, diffing the virtual DOM. And then if I run things in a web worker, you'll notice it's suddenly a lot quieter, right? And what am I doing on the UI thread? Well, I'm doing, okay, the user clicked there. I applied a patch, and I'm doing a bunch of animations, right? I'm only doing the things that the UI thread has to do, which are responding to user input and painting, right? And animations, you have to do that in the UI thread. Another interesting side effect I found with this was that I ended up with this really really nice natural separation of concerns between sort of UI stuff and business logic. So I ended up with these two JavaScript bundles where I had this main bundle and a worker bundle. And the main bundle was pretty small, 24 kilobytes minified in gzipped. And the worker bundle was much bigger. And the reason for that is that the worker bundle, that was basically the app, right? The whole app, for the most part, was just living in this worker bundle. And I also had a service worker, but that's because I made it a progressive web app because that's fun and cool. And you can use both a web worker and a service worker. I mean, why not? You know, these phones have 4 cores. I'm using 3 of them. Why not? But notice that this main JavaScript, this is just containing the stuff that you need to kind of bootstrap the UI, to do things like, to do nice effects and animations and click listeners and like scrolling effects and stuff. And you can ship this down very, very quickly. And I'm also doing server-side rendering. So you can ship this down very, very quickly so that the user immediately gets something they can interact with, something that like is complete from a UI perspective. And then the app itself, which is a bit larger, that can take a while to come down later. And hey, that can get parsed and evaluated on a completely separate thread, right? It's awesome. And I'm not the only one who realized this. Like this is, there's a series of blog posts from this guy, EmpireNode, who demonstrated experimentally that if he puts React's DOM diffing algorithm inside of a web worker, he consistently gets higher frame rates than without. And this is a really, really interesting series of blog posts that he has on this. This has also been done in the Angular world. I actually have to shout outs to Angular too. This is where I got all my ideas from. I totally shamelessly stole these ideas from them. So there is a talk from AngularConf by Jason Teplitz where he shows this app that he wrote in Angular 2 where he tries to scroll, and it's just like, it's a really expensive view operation. So he tries to scroll and it just like freezes his browser. He has to kill the browser. It's pretty bad. And then he just like changes one line of code in Angular 2 to enable web worker support. And suddenly he does the same scrolling operation and it's super smooth. So this is something that Angular 2 is actually adding first-class support for, which I think is really, really exciting, and I really want to see how that turns out. So I think this is a concept that is definitely coming to frameworks. It already is in Angular 2, and in others I think it's coming soon. So in Angular 2, as I said, this is where I got the whole idea from. I saw this tweet from Brian Ford where he said the idea is to run basically the whole app in a web worker and then send rendering instructions to the UI side. And I saw that, and I got super excited. And I was like, yeah, that sounds amazing. I don't want to wait for Angular 2. I want to write it. So the Pokedex app is vanilla. There's definitely some thorny edges with doing it vanilla, but I had a lot of fun with writing it. And then React. So Pete Hunt, who did not react super favorably to my blog post, after he saw the research from EmpireNode, he said, OK, actually, maybe running your whole React app in a web worker could be worthwhile. So hey. Small vote of confidence from Pete Hunt, at least. And then in Emberland, there's this guy, Chris Thoburn, who has done a lot of really, really good research on web workers. He has some blog posts that are linked at the end of the slides. They're super interesting. And he is working on Skyrocket, which is a plugin for Ember that allows you to more easily use web workers inside of Ember. Really, really cool stuff. So the last thing I want to end on is, web workers have been around for a while. Like, when you look at the Can I Use page, what you'll notice is that it actually has support all the way back to IE 10. It's been around since IE 10. And by the way, there are polyfills before that, so if you have to support older browsers, you absolutely can. And you might look at this and think, wow, so web workers are about 5-6 years old, and like nobody's really heavily using them, right? I mean, people are using them. They're using them for mostly like heavy computational stuff. But they're not really, really widespread. So maybe they're not actually that useful. And my response to that is to remind you of another page in the web's history, which was that of XHR. So a lot of people forget this, but XML HTTP request, that was actually introduced in 1999. That came out in IE 5. And then the Ajax revolution, right, Gmaps, Google, Gmail, all that came out in 2006. So sometimes it just takes a while for things to reach like a critical mass of browser adoption, or for people to kind of realize what capabilities they open up. And I like to think that web workers might be one of those things. So I'm going to close with this tweet from Jake Archibald that I really, really like, where he says, prediction, the next generation of JavaScript frameworks will be server first and mostly in a worker. So that server first thing, that's a subject for a whole other talk. But he's talking about the kind of things like Ember fast boot, quick server-side rendering, because we want that quick initial render, initial bootstrap of the app. But then once that app is actually delivered to the user, we want to deliver a rich, immersive, 60 frame per second experience like we're used to with our native apps. And that's what we get from workers. In this case, Jake might be talking about service worker rather than worker because he's the service worker guy. But I mean, it's fine. A service worker technically is a worker, or a web worker. Anything you can do in a web worker, you can do in a service worker. So use them both. They're both great. So what I'd like to ask you to try doing, I think we should all try doing, is let's try taking our applications, our standard web applications. They tend to look kind of like this, right? Where we got one core that's doing all the work, and the other ones that are just kind of sleeping on the job, right? Let's take our applications that look like this, and let's make them look more like this. Thank you.
Come on over, Nolan. That was an excellent, excellent talk. Thank you so much. All right. So who in the Nolan Lawson fan club is here tonight? You know about your fan club, right?
I know. I'm not a member.
No.
I'm scared to join.
So did you make all those GIFs yourself? The Kirby GIFs?
Some of them. I actually learned how to make GIFs and combine GIFs with image magic on the command line, which is way too much effort for a talk, and I would not suggest anyone else learn how to do that. It's painful.
Well worth the effort. Loved all the GIFs. Okay. And I'm glad you said GIF instead of GIF. Sorry about the haters.
Yeah. Old school. Yeah.
So we can tell Kirby's like probably your favorite, like a Super Smash character. What's your favorite Pokemon?
Gengar.
Gengar. Okay, reason?
Well, because normally he's not very strong against Psychic, because Psychic is powerful against Poison. He's part Poison. But you can teach him Psychic, and then that way, as long as he's fast enough, he can get in first and deliver the finishing. I'm talking too much about Pokemon. So.
Did you all get that?
Yeah,
I'm going to go back and play Pokemon later and use this trick later on.
It's a good game.
So you do a lot of work, PouchDB. I love using PouchDB. I think it's great. So did you get interested in PouchDB because of your work doing IndexedDB for workers and things like that?
No, I got into it because I was playing around with it for a side project. And then I noticed some bugs in it, so I submitted a pull request. And before I knew it, I was co-maintaining it. So. Yeah,
so it's cool because PouchDB is really heavily used in Hoodie, which was talked about yesterday by Gregor. And so, yeah, that's all I have for you. Thank you so much.
Thanks.
And next up...